All right, let's do some physics. This is a conservation of momentum problem where we try to figure out if a collision is elastic, inelastic, or completely inelastic. We have a 2 kilogram frictionless cart rolling across a level surface at 6 meters per second when it collides with another stationary 4 kilogram cart, and after the collision, the 4 kilogram cart is moving at 4 meters per second. First thing we want to do is find the velocity of the 2 kilogram cart after the collision, and then we will figure out if this collision was elastic, inelastic, or completely inelastic. To do part A, we need to use the law of conservation of momentum. So I'm just going to define all of my values. Let's call M1 2 kilograms, and we will define M2 as 4 kilograms. V1, the initial velocity of cart 1 was 6 meters per second. The initial velocity of cart 2 was 0 meters per second because it started stationary. V1 prime, the velocity of cart 2 after the collision, is what we are looking for, and V2 prime, the velocity of cart 2 after the collision, is stated as 4 meters per second. So we need to apply the law of conservation of momentum here. This is the big collision equation to find V1 prime. So we are going to solve M1 V1 plus M2 V2 equals M1 V1 prime plus M2 V2 prime. We're lucky in this scenario that because V2 is equal to 0, we can simplify this a little bit. So we just have M1 V1 is equal to M1 V1 prime plus M2 V2 prime. There's no initial momentum in that 4 kilogram cart, so all the momentum in the system starts in the 2 kilogram cart, and that's us accounting for that right there. So I need to do a little bit of algebra to get V1 prime by itself. So the first thing I'm going to do is subtract this M2 V2 prime term. To get it to the other side, I'm going to subtract it. So we have M1 V1 minus M2 V2 prime is equal to M1 V1 prime. And then I just need to divide by M1 to get V1 prime by itself. M1 V1 minus M2 V2 prime, all divided by M1 gives me V1 prime. So I can plug in some numbers and make this happen. And if I do this math, I get 12 minus 16. 12 minus 16 becomes negative 4. Negative 4 divided by 2 gives me a velocity of negative 2 meters per second. So this means that after the collision, the 2 kilogram cart has actually ricocheted and is now going in the opposite direction that it initially was. Part B says we want to classify this collision as elastic, inelastic, or completely inelastic. To do that, now we have to look at kinetic energies, meaning we need to calculate the total amount of kinetic energy prior to the collision and compare it to the amount of energy after the collision. So the initial kinetic energy, so the total kinetic energy is always going to be the sum of the kinetic energy of cart 1 plus the kinetic energy of cart 2. In this scenario, the initial kinetic energy of cart 2 is going to be 0 because its velocity is going to be 0, which makes our life a little easier. So solving for the kinetic energy of cart 1, 1/2 2 kilograms times 6 meters per second squared gives me 36 joules of energy, is how much energy we started with. And then we need to find KE total prime being the total energy of the system after the collision. So that's going to be KE1 prime plus KE2 prime. And in this scenario, both of these values are going to exist because both objects have velocity. That becomes 1/2 m1 v1 prime squared plus 1/2 m2 v2 prime squared. And we can plug in some numbers. We get 1/2 2 kilograms -2 meters per second squared plus 1/2 4 kilograms. V2 prime is going to be 4 meters per second squared. And we can do some math. This becomes 4 joules. 1/2 times 4 becomes 2. And 4 squared becomes 16. So 2 times 16 becomes 32 joules. So this means we also ended with 36 joules of energy. Because we started and ended with the same amount of kinetic energy, that means kinetic energy was conserved. That means the change in kinetic energy was going to be 0. And the type of collision that conserves kinetic energy is called an elastic collision. So our final answer is this collision is elastic because the change in kinetic energy was 0.